name is Camille Mears, and this is the very first video that I've ever tried making of this screencasting. Sorry, I'm just getting over cold. I'm hoping that as the semester goes along, I'll get better at it, and it'll be a good resource for you. So just kind of as a practice and introductory thing, I'm going to put an example on here from section 1 in chapter 2, and this is called a linear equation, because if you look at the x's, they all are of degree 1, so the exponents are 1s, and so when you're asked to solve a linear equation, it's an equation because of this equal sign right here. The object of the game is to get all the x's on one side of the equal sign and all the numbers on the other. The first thing I'm going to do with this equation is that minus 2 in front of the parentheses means minus 2 times everything that's inside. So when I multiply minus 2 times x, you get the minus 2x, and when I multiply minus 2 times minus 3, that's how you get the plus 6. Set that equal to, on the right side, multiply this set of parentheses by 4, everything inside, you get 4 times x is 4x, and 4 times 1 is 4. After you're done multiplying everything by the 4, the parentheses are now gone. So do not write the parentheses in. After you're done doing that, you want to try to combine like terms. So looking on the left side of this equation, the minus 6x and the plus 2x are like terms. And so when you have 6x and you subtract 2x, you get 4x. Notice that the x, which is considered the like part, remains like. So when you add x's to x's, you still have x's. When you have x squareds to x squareds, you still have x squareds. This is with adding and subtracting. The right side of my equation, I have 4x, and then the plus 4 and the plus 4, those are like terms. They're both numbers, and 4 plus 4 is 8. Now I've got an equation. I have x's on both sides, so you want to subtract whatever the x is on the right side. You could do it with the left side if you want, but I always subtract what's from the right side, and you're going to subtract it from both sides of your equation. Now something happens in this equation, does not happen in all of the equations. It happens in this one, and that is when you subtract 4x from both sides, you actually get a little bit more than you bargained for, because 4x minus 4x is 0, and so I have plus 6 on the left side, and on the right side 4x minus 4x is also 0, and I get 0 plus 8. Now when you look at what's left over, 6 equals 8, you have to ask yourself, is this true? Does 6 actually equal 8? And no, 6 does not equal 8. So when that happens, in this case, there is no solution. This is one of the special cases. It will happen once in a while. Sometimes it's called inconsistent. Okay, I'd like to show you another example, and then I have an... Okay, another example from this section, we're still in section 2.1 in the Math 118 book, is x minus 2 over 12 equals x plus 3 over 4 plus 1/4. Okay, again, I know I have a linear equation. Let me write that down. Hopefully my handwriting will get better as I get used to doing this. It's a linear equation because there's an equal sign, which means equation, and these x's again are of first degree. Now this is the same thing as x over 1, so because I have fractions, I'm going to make everything look like a fraction. The nice thing about an equation is you can do whatever you want as long as you do the same thing to both sides. I am going to look at the denominators of all of the fractions and find the common denominator, or the LCD. And the LCD is going to equal 12. So what you do is you take each one of these terms, each one of these fractions, and I'm going to write 12 next to each one. Now, what I'm actually doing is I'm multiplying each one by 12, and this is allowed because I'm doing it to each one on both sides. What ends up here is, well, 12 times x over 1 is 12x. But in this second problem here, this 12 and this 12 cancel out. So no more denominator. Now don't forget that because there's a minus here, when you go to write down the rest of this, you have to distribute this minus through. So minus times x is a minus x. And minus times a minus 2 is a plus 2 equals. Now on the right side, this 4 goes into 12 3 times. So what I get now is I get 3 times x and 3 times 3. And again, yay, no denominator. It canceled out the denominator. And then the 1/4 times 12, sorry, it's crooked. The 4 goes into 12 3 times. We're left with 1 times 3, or 3. Now clean up the sides of your equations. When I say sides, I'm talking about each side of the equal sign. So on the left side of the equal sign, this is the left side, 12x minus 1x is 11x. Just bring down the plus 2. And on the right side, I have 3x, and 9 plus 3 is 12. So you've cleaned up, simplified, combined like terms, whatever you want to call it, as much as you can. And then when you get to this point, you're going to want to get your x's on one side. So I'm going to subtract 3x from each side. That's 11 minus 3 is 8. So 8x plus 2 equals 12, because the 3x and the minus 3x, no more x's. Once you get to this point, you've decided, you've made a commitment. The x is on the left side of the equation, so you want to move the numbers to the right side. I definitely need to practice. Okay, so where is my cursor? The next step then is to move this 2. When I say move, I'm actually doing the opposite operation. So because this said plus 2, in order to move it, I need to subtract 2. Then a plus 2 and a minus 2 cancel each other out, leaving 0. And you always do the same thing to both sides. So 12 minus 2 gives me 10 on the right-hand side. Now I'm down to 8x equals 10. I'm almost there. I'm trying to solve for x. So linear equation, this is what we're doing. Solve for x. So down here, at 8x equals 10, I want to get rid of the x. The 8. So I want to move the 8. Now this is 8 times x. The opposite operation for multiplication is division. So the way you move the 8 is you divide it. You're going to find yourself mostly dividing last. It's very rare that you divide sooner in a problem. That's just kind of like a little hint. Now, when you divide by 8, those 8's cancel out, reduce, and now you've done it. You found x. The right side is just a matter of simplifying the problem. Always reduce your fractions. Never leave a fraction that can be reduced, especially on the final, because it will be marked wrong on the final. Even if it's the right answer, if it wasn't reduced, it'll be marked wrong. Okay, so the last thing I want to say is welcome to YouTube Camille Math. I hope this works out for us. Please give me feedback when you come to class and let me know what I can do to improve. And I'd like to give you a little bonus point for visiting this page. And this is what I'd like you to do. I'd like you to go to your book and go to page 56 and do number 62. Show all your work and bring that to me in class, and I will give you an extra bonus point. Okay, should be a fun semester. Good luck.